All right, wonderful. So let's say that we're not given proportions. Let's say that instead for our sample populations or our samples, we're given the sample mean and the sample standard deviation. So it's always coming back to these one of two cases. Do we have a proportion, or is our data more in the form of a continuous variable where we need to talk about its mean and its standard deviation? So if we have two samples where we've got the mean and the standard deviation, we run something else on it called the t-test instead of our z-test. And for the t-test, t is equal to the difference of our sample means divided by square root of our sample standard deviation 1 squared over its size plus standard deviation of our second sample squared over its size. And then N1 and N2 represent these sample sizes. Okay? So let's turn this into an example and see what happens. So I'm just gonna scooch this over a little bit. All right, so let's say $235 students, answered a survey, on how much they spend at Whataburger in a week. And from that, out of the 150 males, their average of what they spent on Whataburger per week was $10.73. And then for the 85 females in the survey, they spend an average of $13.33 on Whataburger in a given week. So our null hypothesis is that males and females spend the same amount of money relatively on Whataburger. So what we're going to do with the data is use our t-test and figure out, are these numbers a result of just regular random sampling? So are they different just because we're taking random samples and yeah, they should be a little bit different every time? Or are these two different enough that we would want to take note of that and say, either this population or this population spends more definitively on Whataburger in a given week? Okay, so the standard deviation for our males is given as 4.25, and the standard deviation for our females is given as 4.02. So for our t-test that we'd like to check out, we get our t-value equal to y1 minus y2 divided by the square root of S1 squared divided by the size of S1 plus S2 squared divided by the size of S2. So again, to figure out what our normal kind of variance or error should be, we're just mashing the two populations together. So when you run those numbers, you get a t-score of negative 4.66. And that is very significant. So if we want to make some sense out of that number, what we would do is take a t-test or t-distribution. Remember, it's just like a normal distribution, except it's a little bit shallower. And negative 4.66 means that if we took a bunch of different samples, so if we had like, say, I don't know, 1 million students, and we took a bunch of samples amongst males and females and got the mean and standard deviations, then that would mean that these two samples are so different, they would fall negative 4.66 standard deviations from the mean. So what does that mean? Well, 4.66 standard deviations from the mean is like way over here. That's pretty far. Usually past 2 standard deviations, remember we're already down to like 5%, so negative almost 5 standard deviations from the mean, that's very low. So our t-value is very, very, very low. Like it's a lot of zeros after the first decimal place. So what that suggests is when you get a value that's really, really close to 0, and I mean like very close, like there's a whole lot of zeros after that decimal point, what that means is that these are significantly improbable to happen just naturally. So like if we took a bunch of just random samples, a sample like this would happen maybe like 1 in 1,000 times. So either, you know, maybe we picked like the weirdest sample we could randomly, you know, just by chance, or what's more likely explanation would be, yes, there is a difference between the amount of money that males and females spend in a week. So what we can conclude is that, yeah, we can definitely reject the null hypothesis. Males and females, if we separate those into 2 different groups, they spend differing amounts of money at Whataburger. So what this sample is it's so infrequent that it would happen, is it definitely suggests, yes, something is going on here, something is peculiar that makes one group spend more money at Whataburger than the other group. So we can conclude that, yeah, as a general conclusion, that female students will spend more money at Whataburger on average than male students, and that these differences are not attributable to just we took a random sample and the numbers were a little bit different. No, these numbers are so different that it suggests that one group is spending more money at Whataburger than the other. All right, y'all. I'll see you in class. Hang in there. You're almost done. I'm so happy and I'm so proud of all of you for just sticking with it and doing your best. So thank you.